So today's lecture is about AI in cybersecurity, basically. So we all know that AI is potentially having a lot of impact from the threat actor side because threat actors are leveraging it quite efficiently. So they are making new attacks. They're automating their techniques like phishing emails. Very sophisticated phishing emails are coming in the market. So similarly, cybersecurity professionals, they are integrating AI within their tools, within their controls, within their processes. A good example of it is SOAR, right, which is security orchestration and automation platform. So this is how we are basically utilizing artificial intelligence in kind of making our job more easier, I would say, making defense more easier, or defense in depth, I would say. So AI is transforming how we defend against cyber threats. AI-powered tools are revolutionizing threat detection, incident response, and vulnerability analysis, offering powerful new capabilities to combat the ever-evolving landscape of cyber attacks. In which areas are we using these? So we are using this AI in threat detection, incident response, and vulnerability analysis, right? So these are the three domains you'll be covering. That how we can use AI in threat detection, right? So once we usually do manual threat detection, which is quite difficult in a current threat landscape. It's difficult to resolve incidents manually. Obviously, we need something which would help us in identifying, remediating, and creating automated solutions as per the mitigation strategy. Vulnerability analysis, obviously, we already had a lot of scanning tools like Qualys, right? But we still need something, even those tools, to basically use the power of AI in terms of scanning through the vulnerabilities, because vulnerabilities databases are quite helpful in finding the vulnerabilities or correlating the vulnerabilities. Because once the scanner scans your systems, it correlates those vulnerabilities with the vulnerability database, right? We need to automate that process. It's already automated, but just for the sake of explanation or understanding, I would say that it goes there, it correlates with the existing vulnerabilities, and it brings out with the results. So what sort of challenges in traditional cybersecurity? Traditional cybersecurity meaning the cybersecurity which does not really make use of the AI and old cybersecurity, or I would say old techniques or strategies. What are the challenges in that? First challenge is the data overload. The volume of security data is overwhelming, right? It's huge, it's tremendous. There is no limit. It makes it difficult for human analysis. Obviously, our capabilities are very limited. We cannot go beyond the certain limits. So it's make it more difficult to analyze the huge, tremendous amount of data and identify the genuine threats out of it, right? So the data is growing tremendously, and we have a very limited capability to analyze that data for the threats. This is where the AI helps us. It goes through within milliseconds, billions of nodes around the net, and extract the data, required data, or the, in cybersecurity, extract the genuine threats out of that data. What is the second challenge? Evolving threats, right? So cyber attacks are becoming more and more complicated. It's increasingly sophisticated, with attackers employing new tactics and exploiting vulnerabilities. As I said, the threat actors, they are using AI to create more sophisticated threats, to create more sophisticated attacks, which includes highly sophisticated phishing emails, difficult to detect any grammatical mistakes, difficult to detect any graphical mistakes, difficult to detect any spelling mistakes, difficult to detect any layout mistakes or any other anomaly which we used to detect earlier on. When there was no use of an AI, it was easy to figure out that this email is basically a phishing email. But now it's very difficult because they utilized AI to make it 100%, to make it like look like a genuine email. No grammatical mistakes, no graphical errors, no sort of headers or any other things which we could have figured out. And we need to combat using an AI in cybersecurity. And there are various other threats apart from the phishing. Phishing is one of the examples, but there are other hundreds of threats which are basically getting more and more complex in nature. Third challenge is within the traditional cybersecurity is the limited resources we have. Because security teams often face resource constraints, makes it challenging to respond effectively to incident. So when we say resources, it could be the security tools, could be this, it could be the budget to buy those security tools, or in other words, to procure those security tools. Or there are human resources, like we don't have many analysts, for example. We don't have any specialties, right? We don't have any experts. We are lacking behind in that area. So limited resources gives another challenge in terms of the traditional cybersecurity we will be using. So we need to bring in AI. There is a need to bring in AI, integration of an AI automation in cybersecurity to combat these challenges or to combat the complex threats. Okay, now we talk about how AI can enhance cybersecurity. First thing is, which everybody knows, it brings us efficiency in terms of automating threat detection. So when we use AI algorithms, they can analyze vast amounts of data. What was the challenge we had? That we had a tremendous amount of data, right? And to analyze that huge amount of data is difficult. So these are the constraints basically. But we have AI algorithms which can analyze vast amounts of data to identify suspicious patterns and potential threats that might escape human notice. So automated threat detection is the first thing AI can bring in to enhance cybersecurity. What is the second one? Is the proactive vulnerability assessment. When we use the word proactive, that means we use the AI vulnerability assessment before it comes down to us, before it basically attacks us or before we get compromised. So even way before that, we have to find the vulnerabilities within our system. Proactively monitoring, analyzing, and comprehending the threats. AI can scan systems and applications for weaknesses, helping organizations patch vulnerabilities before attackers can exploit them. So this is quite good, right? We are ahead of the game if we use that. And obviously, if we will not make use of it, it would be easy to get compromised. So automated threat detection, proactive vulnerability assessment, and third thing is real-time incident response. Real-time incident response, not like not like after the incident happened or you get too late, or even there is no incident and you're burning down your energies. No. So real-time incident response means the AI-powered systems, they would automate incident response tasks like your playbooks, which security operations they use. Playbooks are basically is a process defining how to deal with an incident, right? So it would tell you how you go about it. For example, if you have an incident and you have a process in place which would tell you if it's a false positive or a false negative. False positive, fine, drop it. If it's a real incident, you can take it further, deal with it, prioritize it, triage that incident, and mitigate it, right? So it's a playbook of processes, right? How you deal with an incident if it happens. So in a real-time incident response, these playbooks would be automated, would be embedded into your current incident response process. When an incident occurs, it would automatically deals with your incident and bring out the tasks or the response which is required from you without wasting your energies, without burning down your efforts on something which is not really an incident. Another example of it, that it isolates the compromised systems and contains the spread of the malware, right? It cuts off the system automatically. The victim system got cut off from the rest of the network so that the malware would not spread across the entire network or the entire file system or the entire directory folders of this within the server. Because this is the problem with the malware, right? This is the problem with the malware. It infects one file or a folder. It's not necessarily remains within that, but it will definitely come out of it. It would infect the other files associated within that same account or within that same device or machine or the server, and whatever contains within that, if there is no stopper there, it would spread across. It would spread across. This is the uh, characteristic of a malware, I would say. It spreads across quickly. If you don't deal with it, you don't remove it completely, it definitely spread across, infect the other files or the folders, and making it or removing it or encrypting it, whatever the form of the malware it got compromised with, right? So with the use of the AI, we are automating threat detection. We are proactively assessing our systems against the vulnerabilities. We are having a real-time incident response, automated real-time incident response to deal with an incident straight away without wasting any time. As I said, time is very critical in these situations because the moment the incident happens, the quicker you deal with it, the less damage it can cause. Okay, so machine learning for threat detection, right? First, it collects the data, then it identifies the pattern, and then it predicts the threat. So this is how this machine learning, this AI, this algorithm uses the threat detection mechanism or technique. So the machine learning models are trained on large data sets of known cyber attacks and security events. Because with every sort of machine learning model, we have to train. In AI, you would learn about it that on every model you have to work out. It's not like it would do it itself, but you got to train your AI model or machine learning model on different data sets, right? In cybersecurity, we train that machine learning model on various data sets of known cyber attacks and security events so that it would have a proper understanding of what threats we are facing, what sort of security events we have to deal with, Then that model identifies patterns and anomalies in real-time network traffic and security logs. Once it is trained, it will have a capability of learning anomalies in a real-time network traffic. First, we give it a training data set with known cyber attacks and security events. Then it would learn the patterns. It would learn how it works. It would apply the same pattern on a real-time network traffic or a real-time data sets, right? In a real-time data, it would do that, whether it would be your security logs or your network traffic. It would identify those patterns or anomalies within that. For what? To detect or to predict threats. So based on those identified patterns, the model predicts potential threats and alerts security teams, right? Because machine or AI or machine learning itself doesn't know whether it's really a threat or whether it's really basically an attack or a malicious thing. But it would based on its based on it would base the predictions on its pattern identification and the learning which it has in the previously we have trained it on the different models or different on a different data sets so that it could identify the patterns. So based on that identified patterns, it would predict that it's a potential threat or a security breach or an alert. It would give it to the security teams that look, this is what I have figured out as per my pattern identification or as per my learning. So we cannot solely rely on machine learning. Obviously, there, there should be a human intervention at some point, right? And at 2 points, I would say. First, you are providing that training or a data set. Then, ultimately, whatever the results you get, it will provide it to you. You got to work on it. What you want to do with that. Okay. So second thing is that this natural language processing for vulnerability analysis. So natural language processing technique, it analyzes source codes for potential vulnerabilities and security flaws. And then AI can extract key information from security documentation and identify potential risks. NLP also processes security advisories and threat intelligence reports to identify emerging threats. So natural language processing, right? Another AI model. It does the code analysis for potential vulnerabilities or security flaws. It does the security documentation. Then it extracts the key information from security documentation and identify potential risks. So you provide him with the code, you provide him with the documentation, you provide him with the threat intelligence feeds. All it does, it makes use of these three. Gets the vulnerabilities out of the code. It utilizes your security documentation, whatever the key information it can extract. And utilizing that key information, it identifies the potential risks. It also utilizes your security advisories or threat intelligence reports to identify emerging threats. So again, you can see here that at this point, you have to provide AI with a lot of data sets, with a lot of information, whether it's your documentation, whether it's your intelligence feeds, you got to embed it in various sources, and then you can train it on those data sets. So natural language processing, you got to research around that. You will have a lot of information on how it utilizes its capabilities and helping in terms of enhancing the cybersecurity. Then it comes down to reinforcement learning for incident response. Scenario simulation, automated response, and adaptive learning. When we talk about scenario simulation, so reinforcement learning agents simulate real-world cyber attacks and learn optimal response strategies. So you give it a prompt in terms of providing it a scenario. You create sort of an incident simulation that is not a real-time incident, but it's just a simulation. Why you are doing that? To reinforce learning agents simulate real-world cyber attacks and learn optimal response. So basically, we are again training it on a simulated environment or a scenario-based learning. It will learn and it will apply those strategies in a real-world cyber attack. It also learns how to automate actions, right? The agent learns to automatically take actions, such as isolating infected systems or blocking malicious traffic. First, it learns it would apply on a real-time cybersecurity attacks, and then it would automate its responses. What are the responses? Either it would isolate the infected system or blocking malicious traffic. It would continuously adopt itself. This is another beauty of it. Whatever it's doing around automating its responses, isolating infected systems, blocking malicious traffic, learning about the real world cyber attacks through the simulated environments, it would adopt its response strategies based on new threat data and feedback. So it gets the continuous feedbacks, it receives a lot of new threats, and it learned around it. Its learning goes on, and then it adopts its learning. It adopts its techniques or responsive strategies based on its learning. So it's all about learning models, right? It keeps on adopting, it keeps on automating. You don't have to worry about writing the new processes, creating the new workflows, or anything else. It does it for you. But there is a problem here. And what is that? Is the ethics, right? So ethics are basically very important in AI. Privacy and data protection, that is another problem. AI systems must be designed to respect user privacy and avoid misuse of sensitive data. After all, we work to protect the data, obviously. So if AI wouldn't be trained properly, in a sense, it's highly difficult to embed those ethics within AI. It can goes beyond the limits. It can basically goes unethically, right? So there are so many possibilities around that. So AI systems must be designed to respect user privacy and avoid misuse of sensitive data. If it gets hold of a lot of user data or a sensitive or a private data, it needs to be that it should respect the privacy. AI doesn't have any emotion? No, it doesn't. Whatever you train it on, it would work accordingly. So you are in command, right? And if you would not design it accordingly, then it would not respect the user privacy and it can misuse the sensitive data. Second thing is the transparency and explainability. What does that mean? That whatever action AI would take, whatever decision AI would take, it should be transparent. It's not like whatever it's doing there and it's showing something else, right? It's doing something bad behind the scenes and it's generating the wrong report. No, it should be transparent. Whatever it's doing, it's visible, it's clear, crystal clear, right? No doubts. AI decisions and actions should be transparent and understandable to humans, fostering trust and accountability so that If the same job a human is doing, obviously that is accountable. How would you bring AI into accountability? So you should design the systems within the same constraints that it is held accountable, and it should be understandable to humans. Third thing is the fairness and non-discrimination. Yeah, discrimination, again, that is again something which is sensitive area. So AI systems must be fair and unbiased. It should not take side to one and neglecting the other, right? It should be fair and unbiased, avoiding discriminatory outcomes based on protected characteristics. Security and robustness. AI models must be resilient against adversarial attacks and manipulation, ensuring the integrity of security systems. As I said, it adapts itself, it continuously improves itself. So it should be in a manner that it should be resilient against adversarial attacks and manipulation, and nobody would do any sort of interference which will harm its integrity or the security of the system. So AI should work in accordance with ethical constraints. It should respect the privacy and data protection. It should be transparent and understandable. It should be non-discrimination. There should be non-discrimination in it, and it would be robust and secure. Because we are at the evolving stage, we are at the beginning, we are at the initial stages. That is why we have challenges. We are training it, we are enhancing it, we are embedding it into our systems, we are embedding it into our security controls. So we have to be careful around various aspects of these ethical considerations. Okay. Now, integrating AI into existing security frameworks. So what are the existing tools and what are the security integrations nowadays? So we have IDS, intrusion detection systems, or intrusion prevention systems. How we integrate AI into it? AI algorithms can enhance IDS capabilities for faster threat detection and improved accuracy. So those firewalls or those intrusion detection systems basically can have AI capabilities for faster threat detection and improved accuracy. Then it comes down to the SIEM, security information and event management. So AI can automate log analysis, correlation and threat intelligence integration within SIEM platforms. Then vulnerability scanners. AI can analyze code and identify vulnerabilities more effectively, providing comprehensive and accurate security assessments. So these are some of the tools AI can embed into and making it more powerful or enhance its capabilities. What are these tool sets? Number one, intrusion detection system or intrusion prevention system, IPS or IDS. And we are talking about firewalls here, right? Next generation firewalls. Number two, SIEMs, security information and event management. Number three, vulnerability scanners. Okay, give more examples. Could be the playbooks for the security operations analysts. It does the job by integrating various methodologies or techniques or the processes within the playbooks, identifying the genuine incidents, saving you the time and effort. Okay. So yeah, let's say, for the sake of an argument, we have everything in place. We have AI embedded into our systems. We have AI playing the role. How we can overcome the barriers to AI adoption in cybersecurity? What are the barriers? What are the blockers which are basically stopping us or delaying us in embedding this AI into our systems. Number one, data quality and availability. As we know, AI models require large, high quality data sets for effective training. We need to train the AI first, right? We cannot just simply embed it into the system to do the job. First, we need to train that model, and those AI models require large and high quality data sets. It's not just any data, or we need to provide it with high quality data. And this can be challenging for organizations with limited data or data quality issues. This is the problem, right? Second thing is we have a skills gap. Organizations need skilled professionals with expertise in AI, cybersecurity, and data science to effectively implement and manage AI solutions. The skill gap will remain there, I can tell you. This is quite important. And for cybersecurity guys who wants to enter into cybersecurity, this is a bonus, right? There will be a lot of jobs, and I always say well-paid job, because the skill gap is there. It will remain. And the reason why I said it will remain is it's ever-evolving landscape. Threats every day, we face new threats, right? So threats are growing at a rapid speed, and we need cyber experts. We always need updated, like who are fluent in the cybersecurity skills, knowledge, and experience. So that is why in this field, you got to enhance your knowledge. You got to study a lot. You got to do the certifications. You got to keep updated with the current threat landscape. Number three is the cost and complexity. So developing and deploying AI-powered cybersecurity solutions can be costly and complex, requiring significant investment and expertise. Yes, it is true. Because cybersecurity solutions are not just like, not talking about 100 or 1,000 pounds. We're talking about the millions, half a million, billion, right? So it is quite costly solutions and quite complex at the same time, which requires not only the investment, but the expertise, the people who will integrate those systems into your environment. A proper integration, and then you got to test it. Then, if it integrated properly, you will give it some time to learn your environment, 5 to 6 months maybe, and then it can start working. So it's a lengthy process, it's a costly process, and it's complex and difficult at the same time. So what is the future then? So we talk about the challenges, we talk about the various systems, we talk about how we train it, we talk about the ethics, we talked about what are the barriers, right? So what do you see future of AI in cybersecurity? So it's enhanced threat detection and automated incident response. This is a few things, important ones we can see. The future of AI-powered cybersecurity. Threat detection would be easy. Threat detection would be automated. Threat detection would be efficient. So AI will continue to advance, enabling more accurate and proactive threat detection capabilities. Similarly, automated incident response will help us in automating our incident response tasks, enabling faster and more effective incident mitigation. It takes huge effort to mitigate an incident, as we know. It's not easy, but with the help of AI, it would be much more easier. That AI has got the capability to correlate with a lot of other systems with databases, or it is trained on the data sets with the similar incidents or simulated incidents. So it knows what to do. Can save us a lot of effort and time. So learning AI is quite important at the same time, as long as you're learning cybersecurity. As we know, AI is a tool set. It helps a lot of other areas. It helps the businesses, e-commerce side. It helps cyber security experts. It helps hackers. Uh, it helps the students, right? It helps the researchers. So it's a tool set which helps in different areas. It gives how to in cybersecurity, how we use it, what is the future of it. So we can leverage it in threat detection and its response basically. We can use it in threat intelligence as well. Very important. Because as I said, it has got a correlation. It can correlate with various nodes or various data sets. So it can collect information which is meaningful to us, which helps the cybersecurity experts in making their decisions. So cyber threat intelligence, incident response, threat detection, and there are various other fields which AI would really be helpful. Right. Thank you very much. Any questions?